People have been dreaming about reading minds for ages. Psychics, magicians, mentalists, employing all kinds of fakery to get attention.
Alam Alasambra.
Mind reading is no longer a fantasy. We can actually do that now, and the secret sauce is artificial intelligence.
New research shows that the tech can help read people's private thoughts.
Researchers have used AI to translate brain scans into text and turn it into what looks like inner dialogue.
I worry that there's a future that we're just not ready for.
This is an image of a giraffe that the computer has never seen, and this is what the computer thinks the human is seeing.
What?
Yeah. So our thoughts are starting to be decoded.
Welcome to the fascinating and slightly scary world of brain-computer interfaces. The prehistory of real mind reading started over 100 years ago when people discovered a thing called brainwaves. Well, they aren't really waves in a literal sense. They are ripples in the electrical field created by your nervous system. For a very long time, nobody really knew how to read those signals or even what they could do. But then, several inventions allowed us to understand them better. And one of those inventions was EEGs.
EEG stands for electroencephalograph, and what it's basically doing is measuring the brain waves that your brain is putting out. When the neurons in your brain spark, an electroencephalograph can pick up the frequency with which they are firing. It measures that electric potential in the brain, and that creates a brain wave pattern that it can measure there.
Now we could see the brain in action, tides and flows of electricity pulsing within the skull. Creating software that would react to those pulses was only a matter of time. And this is how the first brain-computer interfaces were born. Simple thoughts, such as yes and no, up and down, left and right, clear and primitive patterns your brain uses daily and is extremely apt at reproducing. It became a godsend for paralyzed people. However, getting further than that is very difficult. Brainwaves are incredibly weak. An electric field created by an outlet on your wall is orders of magnitude more powerful than the one created by neurons in your head. Also, before reaching a sensor, the waves have to pass through layers of tissue, bone, and skin. If only there was a way to get inside people's heads.
I see a spirit.
The MRI machine reveals the fibers which carry all the brain's thought processes.
It's an imaging technology that allows us to see inside patients and make diagnoses without ever having to do anything invasive.
MRI technology, magnetic resonance imaging technology, looks at oxygen flow in the brain, with the idea being that blood carries oxygen. So as blood is going to different parts of the brain, oxygen's going to different parts of the brain, and that is indicative of brain activity.
In recent years, this method was used to read words and entire images from people's minds, but it's not particularly efficient since there are no pocket-sized MRI machines, and a special algorithm has to be trained on a person for a long time before it's able to read anything. Of course, when we're talking about getting into people's heads, there's always the straightforward way.
Ta-da!
Measuring brain activity directly with electrodes put under the skin or skull is much more efficient. These BCIs are labeled as invasive, and while they require surgery, the results they demonstrate are by far the most impressive.
We're basically using a computer to read Keith's thoughts and then translate that into a machine that then stimulates his hand.
People have been able to control limbs, feel touch, and manipulate objects in virtual space, all thanks to the skull no longer blocking their brainwaves. Elon Musk's Neuralink, probably the best-known BCI startup, is also banking on the invasive technology. And while in many aspects this technology is not that different from regular EEGs, the advantage of being closer to the source of the brainwaves is undeniable. All three of these ways of interfacing have their pros and cons, and all are good at accomplishing certain tasks while being practically useless for others. However, all of them have a common denominator: artificial intelligence. On their own, brainwaves are practically unintelligible. There's no map or chart showing what each impulse could mean. In essence, they're like a merely audible echo of your brain talking to itself. Fortunately, deciphering languages we don't understand is a cakewalk for artificial intelligence.
So I think the main technologies that have contributed to the current rise in brain-computer interfaces is really the convergence of two different kinds of technology. On the one hand, it's medical devices that have always been used to try and measure aspects of the brain and brain activity. And on the other hand is the rise in artificial intelligence that can be used to process the signals from those devices.
The simplest way, and the way most BCIs operate, is to show an AI a lot of data while indicating what each bit represents. After seeing hundreds of brainwaves of people thinking about something in particular, the AI will pretty reliably recognize the same pattern again. This is how scientists generated AI images from MRI brain scans. Even the most expensive commercial BCIs have to go through a lot of training and calibration before almost working. But of course, the technology doesn't stand still. New headsets are being developed, and the software gets better and better at reading brainwaves. Perhaps we're on the brink of BCI prosthetics becoming commonplace. What's next? While superhuman arms are still one breakthrough in robotics away, BCI game controllers are just getting their first commercial releases. Perhaps in a generation or two, they'll be at least as ubiquitous as VR headsets. And in a slightly longer perspective, with all kinds of technology controlled through BCIs, keyboards and mouses will become as old school as typewriters and rotary dials. The vision of the future is quite exciting, but it also brings its own set of dangers. The first computer viruses appeared in the early 70s. By the mid-80s, they were rampant, and cyber attacks became a daily occurrence all across the world. But the concept of cybersecurity didn't exist.
Information is power, and when that power is made available through unguarded information, then it's a threat to all of us in society.
People had little understanding of how to guard themselves against this new threat.
Our major problem is to make sure that the security, that the electronic fences built in these systems keeps up with that technology and with the amount of assets that become exposed in these systems.
And it wasn't until the late 80s that the first antivirus software emerged. And now, we're on the brink of introducing a new technology, one that's going to interact directly with people's brains. Can the same mistakes be repeated again? Can we afford waiting for decades for the concept of mind security to emerge?
Anytime that something is digital, it can be copied, and it can potentially go out of your control. That creates an ethical risk that I think we need to deal with as soon as possible. This goes for your social media data, this goes for your emails, your text messages, everything that's on your phone, your location data, everything. BCI technology takes this to the next level, because the things that you've put on social media, you have at least in some way meant to make this information public. Your thoughts largely are not, and I would argue should not, be publicly available. If you cannot be alone in your own thoughts, you are no longer alone at all.
Autocratic governments use every chance they can to influence their citizens' decisions through large-scale cybernetic blockades. Others conduct elaborate spying operations under the guise of national security.
As long as they can dedicate people, money, and time to the target, they can get in.
Criminals exploit the ignorance and naivety of countless people to scam and rob them from across the world. And various threat actors pretend to be criminals, but are just puppets of their government, conducting cyber terrorism on its behalf. The cyber world is scary enough without computers being able to poke into our minds. And now, if we're not careful, it can become even scarier. Thanks for watching. If you like this kind of content, check out the Explainers playlist on our channel, and share this video with your friends if you like it. Maybe they'll like it too.